Line integrals part two. We're going to look at a different sort of line integral in this section where we have possibly a force field. This is a vector field. 2xi plus xy squared j. Who knows where this came from? We really don't care. If this were force, this unit could be in newtons. If it was in customary units, it would be in pounds, of course. We'll just presume it's in newtons. dr is a small little displacement vectors. That would be in meters. Newtons times meters is Newton meters. This would give us a certain amount of work done by this force field along this path, y equals 3x. Now, first of all, if F equals mi plus nj, dr is going to be dxi plus dyj. And F dot dr, you can dot these, you just get m dx plus n dy. Gives you a scalar quantity that we can then integrate. And normally you can integrate these two parts separately, or you can express dy in terms of dx and do it as one integral. It's really just a matter of choice in most times. So first of all, here's what we're going to do. Calculate f dot dr, and that's equal to 2xi plus xy squared j dotted on dxi plus dyj. And that gives us 2x dx plus xy squared dy. Now, it's just as easy we could do this as an x integral, this is a y integral. If you want to do it all as an x integral, you have to get this in terms of x. I'll do it both ways, actually. You could do integral from 2x dx. X is going to go from 0 to 2. Plus, you can do this as a y integral. X, it turns out, is y over 3, y squared dy. Then we have to get y limits. X goes from 0 to 2. If you put in 0, you get 0. And if you plug in 2, you get 6. So we'll set this up as a 0 to 6 integral. And this gives us x squared from 0 to 2. And that's really y cubed, gives us y to the 4th over 12 from 0 to 6. And that gives us 4 plus 6 to the 4th power over 12. You can reduce that. You can divide one factor of 6 into this, gives you 6 cubed, which is really 216 over 2. Okay, 6 to the 3rd power, 6 times 36 is 216. And then that's 108, so we get 4 plus 108, which is 112. So if this is in newtons, we would have done 112 newton meters of work. This force would have done that much work on the object. Positive amount of work, if this was only force absent friction or some other external force, this would accelerate the object. How much would it accelerate the object? Well, this work would be added to the kinetic energy. Or it possibly could have been if it was, well, we're not going to worry about that. This is a positive amount of work, and if the object was pushed along that path, it would have accelerated it, and you could use that to figure it out. Second way to figure this integral out, let's back up here a second. It's arbitrary which variable we use. We could have gotten it all in terms of x. We could have said this is 2x dx plus x. Y is easy. Y is 3x. And then dy. Well, if you look here, dy is equal to 3 dx. It's just a differential. It's just a simple calc 1 differential. Dy dx is 3, dy is 3 dx. So now we can substitute for dy we can substitute 3dx. And we get 9x squared times x is 9 times 3, 27. This is really 2x dx plus 27x cubed dx. And you can even write that as 2x plus 27x cubed dx. And now, of course, we want to integrate this. From 0 to 2, and we get x squared plus 27x to the fourth over 4 from 0 to 2. That gives us 2 squared over 4, and then 16 times 2 to the fourth is 16. 16 over 4 is 4. 4 times that is 108. And sure enough, we get the same answer, 112. So it's largely a matter of choice. So, okay, that's all for this video. So.